Hey, my name is Amanda Frazier, and this is my Matlab project. It's basically approximating certain functions using the Taylor series expansion, and I'm just going to get started to kind of explain it. So this gives you an overview of what it does. We're going to explore e to the x, the natural log of x plus 1, and the sine of x, using a certain amount of terms based on what the user inputs for the Taylor series expansion. And then we're going to go ahead and graph the approximate graph as well as the actual graph in order to compare them. Another feature of the program is that we're going to explore e to the x and see basically if you choose a certain amount of terms between 1 to 10, how close you're going to get to the actual value using this approximation. So let's go ahead and get started with e to the x. So you just type in 1. And how many terms would you like? Let's start with something small like 3, and we'll go from 0 to 3. And it's going to show this, this green graph is the e to the x, and then this dotted pink graph is the approximated value. And basically, the more terms you choose, the closer it's going to be to this e to the x. So we'll go ahead and see that now. So let's choose e to the x again, and instead of 3 terms, let's do something like 9 terms. And we'll go from 0 to 3 again, and you can tell that it's a lot more accurate or close to the actual value. Let's go ahead and do the natural log of x plus 1. So we're going to type 2 in. And let's do 5 terms. And here we'll go from 0. And it says, note that this approximation is good for x values close to 0. So you don't want to go with something too high. So let's just start with 1 and see what it comes up with. So with only 5 terms, it is pretty close to the actual graph. And I'll show you what I mean by that it's not good for x values that are far away from 0. So let's choose natural log of x plus 1. And let's go ahead and do 5 terms again. I'll go from 0 to like 3. And then you can see that as you get further from 0, it's completely going down when the actual graph is going up like this. So yeah, you want to choose values close to 1, and that's just basically based on the Taylor series approximation and how the summation works. Let's clear this and show you if we do for the sine of x. It's basically very similar. We'll start with something like 3 terms. We'll go from negative pi to pi, and it's pretty accurate already. And I'll show you what it looks like with a larger graph. So we'll do Taylor again. We'll do sine of x. We'll do 3 terms again, but this time we'll go from negative 2 pi to 2 pi. And then as you can see, there's a graph. And as you choose more terms, you're going to get closer to this actual graph here. The last cool feature of this program is that we can investigate the number of terms of the expansion of e to the x, and it'll make more sense as I go through it. So let's say we choose something like 4 terms, and now you can choose what x value you want, so we can approximate like e to the 0.2. And it's going to show you that the Matlab value would give you 1.2214, and the Taylor series value with 4 terms will give you 1.2213. So you can see that's very accurate. Then, no matter how many terms you choose here, it's going to display a graph from 0 to 10 terms. This blue line is the actual value, the Matlab value of e to the 0.2. and then these dots are the approximated value based on the number of terms. So I'll show you one that I'll do this one again. So 4, let's do 8 terms, and we'll do e to the 3. Okay, so with 8 terms it's still going to be fairly accurate. The actual value is around 20 and the approximated value is 19. Then you can look at the graph and it'll show you as you get the more and more terms you sum up, the closer you're going to get to the actual value of around 20. And this one I used user-defined functions for, but the other ones I used for loops for, and so I'll show you a little bit of that. So over on this side, this is the code for the main function, or the main program, and it'll display all that information, background information. And then I use if and else ifs to call certain programs up based on what the user inputted as their function. So if they choose 1, it'll go to the Taylor exponent, else, and it'll go to all these different programs. And then I'll show you the inside of the e to the x program. Again, you input your terms. We have an x array depending on what the user inputted as their x-min and x-max values. The y starts at 0 because in the for loop we're going to be adding to it every time, because the Taylor series is a summation process, and it'll go from 1 to the amount of terms that the user chose. And then this is just the Taylor series summation. And then I also had a y-min and y-max based on for the graphs based on what the user inputted for x-min and x-max, and that's used when we plot it. Oh, here it is. For the axis when we plot. And then I also want to show you the inside of the exponent based on the terms, the last function program we did. In this one, this is where I used the user-defined functions. I created a bunch of exponent to the 1 and everything, and graphed based on those values. You got to choose the amount of terms, or actually this is the x value, so e to the q, whatever you wanted to approximate. And here are those functions. I just wanted to show you those two. And yeah, that's pretty much my program.